Hi, my name is Kelly Mahoney, and I'm a research scientist with the Cooperative Institute for Research in the Environmental Sciences located here in Boulder, Colorado. I'm actually standing in front of Boulder Creek today with a flood memorial marker behind me. We'll talk about it more as we go, as I'm going to be talking to you today about flooding in the western U.S. So some topics that we will cover in the next 10 or 15 minutes are looking at the difference between a river flood and a flash flood, understanding what causes flash flooding from both a meteorological and a hydrologic perspective, looking at the sort of meteorological ingredients that go into a flash flood, understanding why flash flooding is more of a risk in the western U.S. relative to other parts of the country, and also talking for a couple of minutes about what happened in the 2013 Front Range floods, which was a recent, very high impact event that occurred, again, right where I'm standing. Starting off with just a couple of definitions of a river flood versus a flash flood. A river flood is defined as an overflow of water onto normally dry land, and it's caused sort of by slower rising water in a place that usually has it. So whether that's a river, a stream, a drainage ditch, again, it's just when water can no longer be confined within those banks and it rises and floods the dry land next to it. It's a longer term event. It usually lasts on the order of days to weeks. A flash flood, on the other hand, is a much shorter term event. We usually talk about it happening within about a 6-hour time frame, so the precipitation would fall and a flood would result, again, on the order of sort of minutes to hours, up to about 6 hours. It's usually characterized by really raging torrents of water. It's just when water can't be absorbed by the surface underneath of it, and so it goes where it needs to, and so it can happen very quickly and become very destructive. Again, these are shorter term events and they often take people by surprise. So when we talk about the number of deaths caused per year by flooding, often flash flooding is the culprit for fatalities. Talking about a couple of causes and sort of main components of flash flooding, we obviously need a heavy or excessive rainfall event to give us that flood. But when we talk about that amount of precipitation falling, we can think about it in terms of both intensity and duration. So the intensity of rainfall is simply the rate at which it falls. You can think about maybe a 30-minute thunderstorm where rain is falling very heavily, very intensely, and can lead to a flash flood. You could also consider sort of a more moderate type of weak thunderstorm, or simply an everyday sort of rainstorm. But if it persists for several hours on end over the same area, you can also have a flash flood occur. So we sort of have this spectrum of precipitation events that might give us a similar flood on the ground. Most flash flooding in the western U.S. is caused by slow-moving thunderstorms. So we think of them sort of as a summertime, warm season event, but that's certainly not the only way that we see flash floods. Considering the topography, the soil conditions, the ground cover, and the type of terrain that we're dealing with is something that we certainly can't ignore when we talk about flash flooding either. And it's also worth mentioning that you can have a flash flood occur even if no precipitation has occurred, and that can happen when you have a dam or a levee break suddenly, or even a debris or an ice jam in a river open up all of a sudden. And these types of events can be very destructive to downstream communities. In fact, one such event happened a few decades ago now in a town very close to here called Estes Park. It's the Lawn Lake flood, and this is a very famous event which you can find lots of startling and dramatic images of that. So going back to the more common type of flash flood though, the ones caused by intense rainfall, how do we get that out of the atmosphere? We, as meteorologists, like to talk about sort of three main ingredients that can lead to intense precipitation, and you need to have moisture, lift, and instability in sufficient amount to get that intense rainfall. So moisture occurs from a number of different directions for the Intermountain West. We can get it from the Pacific Ocean, the Gulf of Mexico, and some preferred pathways up through the Gulf of California. So how you get that moisture is one thing, but you also need it to sort of persist and build up. And forecasters like to think of a dew point of about 55 degrees Fahrenheit as a threshold at which they start to be concerned about flash flooding. Lift is important because the way we make rain in the atmosphere occurs when we start to lift air close to the ground up high enough in the atmosphere so it condenses and forms the liquid that will eventually become rain. So how do we get lift here? It usually happens when you have a wind setup where you are basically funneling wind against the mountains and has nowhere to go but up. So that provides a nice, easy source of lift for our region. Instability is similar to lift in that we need air to rise, but it sort of more links to thunderstorms in the sense that when you heat a surface, especially in the summer, when you heat it very quickly, that warm air close to the ground becomes buoyant and it rises very quickly. That quick rate of ascent is linked to an intensification of precipitation, and so that is why that third ingredient can become very important in those various sort of flashy, very short time scale events that occur during our summer months. So rainfall intensity, again, that combination of moisture, lift, and instability is not all that we need to get a flash flood here. We also need that idea of a long enough duration event. And again, slow-moving thunderstorms certainly give us a good portion of our flash floods, but it's not the only mechanism. We can see stationary fronts, we can see slow-moving cold fronts, we can see just a slow-moving atmospheric pattern set up by which rain can be produced for hours on end and again give us a flash flood. We also have stationary boundaries in the mountains in that the underlying surface certainly isn't changing, and so if the atmosphere again is conducive to that rainfall, it has this stationary unmoving boundary underneath of it to continue to generate that lift. Finally, the surface hydrology, again coming back to the fact that the rain falling out of the atmosphere is only really half of the story. What happens when it hits the surface is extremely important to determining how intense and how destructive the flood may become. So one consideration would be soil conditions, whether the soil was saturated, perhaps it rained in the days leading up to an event and there's already water in the soil. So when more rain falls on top of it, it has nowhere to go and it has to go over and cause a flood. There's also just sort of, other surface conditions such as paved surfaces, impervious surfaces caused from wildfire scarring, urban settings, and so on that can also increase the risk of flooding. Again, also considering the fact of the terrain in the Intermountain West, when you have a lot of rain falling onto the mountains, it's very steep grades, all of that water gets funneled into very small areas in a short amount of time, and it all just sort of escalates and accelerates the flood timescale. So speaking specifically to the Intermountain West and why there's enhanced flood risk here, we've already covered a number of these ideas in the sense that we have this terrain, we often have rocky soils, less pervious conditions. So hydrologically speaking, there are a number of reasons that make this area at risk for flooding. We also have some sort of preferred moisture pathways by which moisture can get from those sources into the Intermountain West. And so on a map you can kind of see highlighted areas where we've seen certainly very well-known historical events in the past, and you can also sort of envision, based on terrain and perhaps how moisture would get into these places, why there are certain hot spots essentially for flash flooding. Some of those would be the Front Range of Colorado, portions of southern New Mexico and Arizona, the mountainous parts and the foothills in Idaho, and so on. However, it's worth mentioning that really the combination of terrain and the fact that we really can get moisture into most parts of the Intermountain U.S., given a certain atmospheric setup, everyone is at risk for the potential of flash flooding. It just tends to happen more frequently in some places rather than others. So speaking a little bit to the 2013 Front Range flooding, again, I'm standing here in front of Boulder Creek, where in some ways this was sort of the epicenter of parts of the Front Range floods. The memorial marker behind me, it's a memorial to Gilbert White, who was sort of the father of floodplain mapping and management. It has different flood levels on it. Fortunately, here in Boulder, the waters really only reached what's called a 50-year level, so sort of at my waist height here. But obviously, we have known events that have gone up much higher on the memorial marker, and in certain parts of the Colorado Front Range we got to those levels. So this was a very high impact destructive event. Again, it happened in September of 2013. Almost 18 inches of rain fell in an area that normally doesn't exceed that amount in a year. 10 people perished in the floods. Several $billion of damage were done. There were many dramatic tales of highways being destroyed, leaving communities isolated for days. And so again, widespread, long-lasting, high impact, but it was really anomalous and of interest to scientists and researchers for a couple of other reasons, beyond just the sheer number of people that were affected. For one, the breadth of this event, so sort of the spatial extent of the event, was so much larger than what we typically think of than just a summertime, localized, thunderstorm-driven flash flood. It affected a large portion of the state in northeastern Colorado. The duration of the event, we experienced rainfall, not continuously, but on and off for a good 7 days. The timing, in terms of the seasonality, was fairly uncharacteristic. This event occurred in September, which is not normally one of the wetter months for this part of the country. We set records in terms of the amount of moisture that was being held in the atmosphere, and that also occurred for several days in a row. And again, one of the more unique aspects of the event, we use the term timescale transcendence in a recent paper published about the event, but really that's just a way to say that this was a really striking example of very short-term flash floods occurring on the scales of tens of minutes, instantaneously as these heavy rains hit the steep canyon walls, transcending essentially into days and weeks of impact as the water started to move into the eastern part of the states. Flatter terrain, larger rivers, things spilled out onto the plains, and again really impacted communities there on a much larger time scale. So circling back and recapping what we've covered today, the basics here, that flash floods are short-term events. They can be quite dramatic, quite damaging. River floods are longer term, sort of slower rise types of events. They occur more on the time scale of days and weeks. Flash floods are caused, on a basic level, just generally when intense rainfall occurs over an area that can no longer absorb that water. And so the water has nowhere to go and creates its own pathway, essentially. The western U.S. does see an enhanced risk of flooding due to a number of factors. The steep terrain, sometimes less absorbent soil conditions, and also the fact that we have a number of atmospheric sort of setups that are conducive, again, to moisture sort of pooling and sitting in an area and leading to a slow-moving atmospheric condition that can give us flash floods, or can give us the intense rain to lead to flash floods. And then finally, again, standing here in front of Boulder Creek, where we saw some large impacts in the September 2013 floods. This was an event that was abnormal for a number of reasons. It happened over a very large area for a long period of time, affected a lot of people, and really connected that spectrum of short-term flash flood events to a longer-term river flood event. That recent event has also led to a lot of interesting questions for researchers and meteorologists, and if it has sparked some questions and interest in you, I hope that you will check out some of the links provided at the end of this show. And in the meantime, I thank you for your time and appreciate your participation in this course.